This video is going to go over how to calculate your linear regression equation or find your correlation coefficient using one of three options. We're going to look at using our calculator, using StatCrunch, and then also using Excel. So I'm looking at an example here from my statistics class, chapter 4. And so if you're using the MyMathLab, anytime they give you a data set, even if it's just a small data set like here, there should always be a little blue box up here. And if you click on that box, it's going to say that you can open in StatCrunch or open in Excel. And so what that does for us is we don't have to worry about making sure we type in all the data correctly because it's already going to be typed in for us. And so that's definitely a larger data set. Now this one's not a very big data set, right? So it might not be that bad to put in the calculator. So I'm going to pull my calculator up here. Later, we are going to go to Stat and Edit. We're going to put in whether we're putting it in to count or we're doing it for probability later on. We're going to go Edit. And then we're just going to type our data in here. A few tricks when we're using list, the whole list, and you don't want to have to go through and delete each item. If you go up to the top and do clear and enter, that will clear the whole list for you. So that usually is a time saver. Now the way they've got it written out over here is they've got it done horizontally, right? But we're going to put our data in. It's going to be all the X values. So we're going to put in 1, 4, 7, 7, and 9. I don't know what happened there. Sorry. I really thought I only hit 9 once. That, and then we're going to type in 1.3, 1.9. All right, so before we do our linear regression, once you have the data in the list, you want to make sure that both of your lists are the same length. If they're not, if you accidentally typed in something twice in L1 or you forgot a number in L2, what's going to happen is when you try to do the linear regression, you're going to get an error that says invalid dimensions, and that's basically you don't have the same number of X's and Y's. So just go back and check on that. Data typed in, it's automatically just saved in there. So we will go to Stat and over to Calculate, and we're going to do number 4, which is linear regression. So the AX plus B. Then here we're going to tell it where our X and where our Y values are. If you put them in a diff 3, I would go to second and 3. And that's how I get the L3 in there. Okay, so for L1, I'm going to do second 2. We don't have a frequency list for this one. We don't have to do the store regression equation. That's kind of an extra thing that you can do, but it's not something that we have to do to get the equation that we want. And then we're going to calculate. All right, and so then I get the equation of the line. So the A is the slope and the B is the y-intercept. And so then just depending on how many decimal places we needed, we would put it in so we would get the answer correct in MyLabs. Now you notice on this one, it doesn't have the R values. And so if your calculator looks like that, that's something that you do want to adjust, get the R values to show up. So let me show you how you would get those if you haven't figured that out. You're going to go to log is, and then you basically just want to arrow down until you get to, these are all alpha, and we're going to push enter, and then enter again. All right, and so once it says done, then you can go back and do the linear regression again. Also have the R squared and the R values. So if you have a problem that just wants to know the correlation, you can use this and just get the R value or the R squared, but everything is kind of included in there. So once you've turned the diagnostics on, then you'll be good. It'll stay that way forever. All right. So that would be how we do it in the calculator. If we're going to do it in Excel, what we'll do is we would click on that button and we can say open in Excel. Right, and so then we're just going to say yes, we want to open with Excel. Now, of course, to be able to do this, you do need to have Excel downloaded on your computer. Students do have access to a free version of Microsoft Office. So if you haven't downloaded that and you have questions about it, let me know. But there are instructions on KCTCS's website, or I can send you some instructions if you can't seem to get it to work or you can't find it. So you do need to make sure that you enable editing, otherwise you won't be able to work on it. And so now we've got the data here. So like I said, this one was kind of a small data set, but if you had a long data set, you know, maybe 30 data points, right? It's just automatically there. This one tells us, you know, these are the X values and these are the Y values. So it'll have headers. If there's certain labels, you know, if we know what X and Y are, they'll be labeled that way. So what we can use in Excel is something called data analysis. So if you go to the data menu item up there, data analysis is what we're going to use. Now, if you've never used this before, it may not be in your menu. So what you need to do to add it in, it's a free add-in. You just have to add it. So go to File. And then we're going to go all the way down here to Options. All right, so options, we're going to go down here where it says Manage Ad, we're going to click Go. All right, and then all we have to do is, this one won't be checked if you don't have it, so we'll go in there and check that Analysis Toolpath and just say OK. And then it will show up when you go to the Data tab, show Data Analysis there. All right, so data analysis can also be used kind of like the one variable stats is used in the calculator. That's how you can get the mean and the median, standard deviation, all that stuff at once. With the data analysis, if you want those kind of things, the mean, median, mode, standard deviation, then you're going to use I think it's descriptive statistics here, and that would tell you all those things I was just talking about. But we want to do regression, right? So if I go down here, I can see regression is an option. So I'm going to say OK. And then it wants me to highlight the Y values. Okay, so make sure the cursor is in there flashing, right? And then I'm going to go over here and just highlight the numbers for the Y. And so it said my Y values are going to go from B2 to B6, right? And that is correct. Then click on the X, right? Make sure it's flashing there, and then highlight the X values. All right, and then this is just asking where you want the data to come out, like where do you want the regression equation? Do you want it to print out in its own workbook or on a worksheet or whatever? So I usually just have it print out right beside my data. That way it's all together. So I'm going to click Output Range and again put my cursor in here and then just click anywhere on the page. That's where it's going to start printing out. Also, we'll do the line fit plot. That's going to show kind of what the scatter plot looks like. You don't have to do it though, but that's usually what I will click and then OK. All right, so with this, you are going to get a lot of output. Some of it you don't really need, but this is going to be what your output looks like. So let's a little bigger so you can see what all these values are. So the ones on top, these are going to be your R values. And so what we're interested in, oops, sorry about that. We would be interested in one of these two, maybe both. But the multiple R is the R value that we would get in the calculator. So, you know, on the calculator, we got 0.98528, right? Same thing here. And then the R squared, of course, is the R squared. So those would be the two values you might need from that. Down here, this is actually where the slope and the y-intercept are. So this is the intercept, and that is the slope. And we could again check that with the calculator. And it's the same, right? 0.2015 and 1.07. So we got the same thing there. So that's really need out of this, all this data. You really just need those values. All right. So that's the main thing, is just knowing how to read the output, right? Once you get it. And then this over here, that would be our scatter plot if we need that. I think like I would ask, like, you know, what the data would look like. So we can, you know, make it bigger here. What this shows is where all the Y values actually were and where the predicted Ys were. So that's what the orange are. But if I just want to see the original scatter plot, I could click on the orange dots and delete them. Just push delete. And then you kind of get to see where the actual scatter plot, you know, what it would actually look like. And so that way you could kind of figure out which one matches the best to that. Okay, and so that's how we can use Excel to find our regression equation, and then also to find the R value or to look at the scatter plot. The next option that we have is StatCrunch. StatCrunch looks a lot like Excel, but if you haven't used my stat lab before, then you've probably never seen StatCrunch, because it is something specific to the Pearson program. That will open up a new window that you can work from, but just like when we used Excel, the data will be transferred right into the StatCrunch program, so we won't have to worry about typing it in ourselves. So StatCrunch is a lot like Excel, or at least looks like Excel, in that it has, you know, the columns and the rows. But what's a little easier with the StatCrunch is that you don't have to necessarily know formulas to type in or anything like you do in Excel. Mainly what you do is just kind of go through here and figure out, you know, what do I want to do, right? You can do some other things here that we would use in later chapters, chapter 7, 8, etc. But we are going to go down here. So we're in stat, we're going to go to regression, and we want to use just the simple linear regression. So we'll click on that. All right. And so this is sometimes what I think look a little scary, is options that they have in here. Most of the time we don't really need all of it. Let me make this a bigger screen here. But so most of the time there's going to be more than what we really need. We usually just kind of want the basics. But our X variable is going to be the X stuff here. Nothing there. Really all we need is, we might want the fitted line plot. Again, that's going to show you kind of the scatter plot. There's some other things. Again, we don't really need any of that. We don't really need any of these things, okay? We just want the basic equation. So that's all we'll have to do, okay? So the only thing we really did was choose X and Y, right? And then if you want to see the scatter plot, you can do that fitted line plot. And then we're going to push compute. All right, and then you get this here, this little output. And again, like the one we saw in Excel, you do get kind of a lot of output, right? But we want this up here. So this would be our equation. So you can see it matches the same one that we had in the calculator. They do write it backwards to what you might be used to seeing. Usually we're used to seeing the slope first and the y-intercept. That's not always the case in statistics when we're doing especially like multiple regression later on in other classes. But that's just how they have it here. So just be aware of that. The first number is actually the y-intercept here. And this is the slope because it's with the x, right? What the regression equation would look like with the actual y values. So basically looking at the predicted y versus the actual y values. And so that's the three ways that you can find a regression equation or find a scatter plot if you want. And hopefully that will help you some as you're working through chapter 4. Let me know if you have any questions.